All right, so we're going to look at some more electron configurations, only this time we're going to look at ions as opposed to neutral atoms. So just as a reminder, it kind of helps if I think about helium as being over here in the 1s2s. Right, and then I fill up first my 1s, and then 3 and 4 come next. They go in the 2s, and these guys over here are the 2p's, then the 3s's, then I fill the 3p's, then the 4s's. Remember the d's are one less, so these are the 3d's, back up to the 4p's, and so on. So in this case, they're asking about nitrogen 3-, right? So if nitrogen has a -3 charge in this case, it has gained 3 more electrons than it had when it was neutral. So nitrogen is here, so if it gained 3 electrons, it's going to have the same number of electrons as neon. So when I ask for the electron configuration of N3-, you can think about that as if I'm asking for the electron configuration of neon. And so I'm first going to flip the 1s's, so 1s2, then I have 1, 2 in the 2s's, so 2s2, and I go to nitrogen plus 1, 2, 3 more, so I have 2p6. This is electron configuration of N3-. Okay, our next example, we're looking at a positive ion. This time we're looking at calcium 2+. So if it's positive 2, that means it's lost 2 electrons. So here's calcium here. It has 20 electrons when it's neutral. If it loses 2, that means it's going to look as the same as argon. And so I start here with my 1s2, then the 2s's come next, 2s2, then the 2p's are going to be full, so 2p6, 3s2 is next, and then finally 3p6. So calcium 2+ has the same electron configuration as argon. Okay, in our last example, we're going to look at the electron configuration for iron +3. Now the transition metals are a little bit unusual in that when you're filling up the electrons, you go the 4s first, and then here's iron, and so the electron configuration for iron would end 4s2 and then 3d, 1, 2, 3, 4, 5, 6. So it would end 4s2, 3d6. However, when I make ions, in this case iron has lost 3 electrons, I take the s's, the 2s's away before I start taking away the 3d's. So I would take away the 2 4s electrons and then 1 of the 3d's. So to make that a little bit more clear, I'm going to write the electron configuration for neutral iron first. All right, so iron is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now when I go to iron +3, iron loses the outermost s electrons first. So when I take away 3 electrons, I'm going to take away the 2 4s electrons and 1 of the 3d's. So iron +3, the electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6. I've taken away the 4s's first, so then I'm left with 3d5. All right. So with transition metals, I take away the outermost s electrons first when they're ions, then I start taking away the outermost d electrons.